You have cancer. 3 words. That's all it takes to turn a life upside down. That's all it took to change my family's life forever. See, when I was a little girl, my nana, or my maternal grandfather, was diagnosed with late-stage cancer that would eventually end up taking his life. But his diagnosis came at a time where no treatment could make a true impact on his health. Now imagine that most of you in here have either heard of similar stories or have been through one yourself. Because let's be real, this experience is not unique. In fact, countless people every single day face similar battles, receiving such life-altering diagnoses. But instead of just saying countless people, let's actually make it a lot more real, which is why I want you all to take a guess. How many people are diagnosed with cancer every day? Let's get a show of hands. How many of y'all think option A is correct? What about option B? What about option C, which is 5,500? And finally, what about option D, which is 7,000? Come on, let's get a show of hands. Well, for those of y'all who thought option C, or 5,500, you're absolutely correct. In fact, in recent years, cancer incidence or occurrence has been steadily rising, and with it, the frightening battle that surrounds it. Because as a common man, when we think of this disease, we tend to think of a battle, a loved one, and death. Now, this association is not new. In fact, it dates back centuries, all the way to ancient Greece. Now, speaking of ancient Greece, a lot of you guys might know Hippocrates, the father of medicine, who drew inspiration for the word cancer from the word crab. He observed that just like a crab's legs, tumors had finger-like projections that spread outward, gripping onto the body. For centuries, this is what our battle with cancer felt like. Impossible to contain. But as time passed and our understanding grew, it led to the creation of what we believed was our most effective treatment, chemotherapy. This is an approach that essentially utilizes cytotoxic drugs that travel through the bloodstream to target rapidly dividing cancer cells. But there's a catch with this too, because these drugs don't know the difference between healthy cells and cancer cells, so it ends up attacking anything that grows quickly, like the healthy cells in your digestive system, bone marrow, and even hair follicles. Now, while all of these might seem like flaws that surround chemotherapy, its actual most fundamental flaw comes from its generalized one-size-fits-all approach, where a majority of cancer patients are actually prescribed with the same standardized doses and regimens, without even taking into consideration the type of cancer they have, its genetic makeup, or how the patient's body might even respond to it in the first place. This causes chemotherapy to be sort of a hit-or-miss approach, where some patients will undoubtedly respond well, but for others, it could be detrimental to their health. Now, this does not have to be the reality that we accept today, because slowly but surely change is coming, where early detection through something as simple as a blood test can change the entire course of the disease. A key player in such a shift? Biomarkers. But before I dive deeper into what biomarkers are, let's take a moment to understand the impact of early detection. A study by the National Institute of Health earlier this year reveals something extraordinary. Between 1975 and 2020, about 4.75 million deaths were averted due to early detection and screening alone. Take a moment to let that sink in. Now let's talk about a key player that makes all of this possible: biomarkers. Now, the textbook definition of biomarkers is that they are biological molecules found in our tissues or bodily fluids like blood, urine, stool, and saliva. But it goes a lot deeper than that. See, biomarkers are like tiny flags or signals that our bodies produce. They're measurable indicators that tell us exactly what's happening in the tumor microenvironment, telling doctors precisely what's going on at the molecular level within the patient's cancer. Now, these biomarkers come in 2 key types: inherited and acquired. Let's talk about inherited biomarkers first. Now, inherited biomarkers are genetic traits that you're born with. They're clues that run through your family and can signal if you have a higher risk for a certain type of cancer. Now, for instance, take breast cancer, for example. See, women who are born with a mutation within the BRCA1 or BRCA2 gene actually have a 60% higher likelihood of developing breast cancer throughout their lifetime, compared to just 13% in the general population. Now let's talk about acquired biomarkers, which are entirely different. There are changes in your DNA, proteins, or other molecules that happen throughout your lifetime. Now, these biomarkers can result due to mutations within the tumor cells or other cells due to factors like environmental exposure and lifestyle choices. Now, on top of all of that, these biomarkers are groundbreaking because they tell us exactly what's happening within the tumor cell. Now, take ctDNA, for example, which is circulating tumor DNA. Now, these are small DNA fragments that are spread into your bloodstream by tumor cells. Now, these DNA fragments, while small, are mighty because they tell us precisely what's happening at the molecular level because they're like detectives in our blood. But why is this all so important? And the answer actually narrows down to biomarkers' 3 key utilities: diagnosis, treatment, and monitoring. Let's talk about diagnosis first. See, biomarkers don't just tell doctors if a patient has cancer, but rather what type of cancer they have. By identifying specific genetic mutations that differ one form of cancer from the other, biomarkers can make diagnosis a lot more precise than what it used to be due to traditional imaging. Now let's talk about treatment, which is actually where biomarker testing truly shines. See, through the use of something called predictive biomarkers, doctors are now able to customize treatment for the patient based on the specific genetic mutations of that tumor. Now, on top of all of that, this type of testing can save a lot of money. See, we all know that traditional cancer treatments like chemotherapy come with a hefty price tag. But now, by utilizing biomarker testing, we can identify patients who might not even need such aggressive and expensive treatment in the first place, helping significantly reduce their healthcare costs. And finally, let's talk about monitoring. See, after giving these patients these drugs and treatments, doctors are able to use biomarker testing to identify whether the tumor is even responding to these treatments in the first place. Now, you all may be wondering, where does this all lead us? And the answer is, it leads us towards something called a tumor-agnostic approach to treatment. But that sounds like a lot of jargon, so let's actually break it down. See, doctors first used to classify cancers from where they occurred within the body, like breast, lung, or colon cancer. But now, by utilizing biomarker testing, they're able to zero in on the specific genetic mutations that drive that tumor. And this naturally leads us to something called precision medicine, which is exactly what it sounds: precise medicine. And it takes things a step further by tailoring these treatments for these patients based on their specific disease-specific biomarkers. Now, a major part of this evolution is actually something called immuno-oncology, which is a field powered by biomarkers. This is all about using the body's own immune system to fight cancer more effectively. Now, let me let you guys in on a secret. Our immune system is pretty smart. It knows how to tell the difference between healthy cells and those it sees as threats, like germs or cancer cells. Now, this is made possible through the use of something called T cells, which act as the immune system's soldiers, attacking anything foreign while leaving the body's own healthy cells alone. Now, to regulate this entire process, the body uses something called checkpoint proteins, which work like on and off switches to control immune responses. Think of them like traffic lights. Just like cars respond to the red and green signals that these traffic lights give, these T cells respond to the on and off switches that these checkpoint proteins give them. But that's exactly where the problem comes in. See, our cancer cells are even smarter. They've figured out a way to hijack these checkpoint proteins, essentially allowing them to continue growing unchecked. Now, to understand this better, let's actually take a look at one of the key players in this game of cat and mouse, PD-L1. Now, PD-L1 is a checkpoint protein found on T cells, and it works like an off switch after binding to another protein called PD-1. Now, PD-L1 is commonly found in healthy cells, which is good because that means the T cells won't attack something that's actually good for us. But there's a problem, because PD-L1 is often found in cancer cells as well, which means after binding to PD-1, they can basically hide in plain sight while our T cells do absolutely nothing and stand in the corner. Now, to counter this, scientists have recently developed something called monoclonal antibodies, which work to turn the immune system's off switch back on by targeting either PD-1 or PD-L1. Now, by doing this, it's important that we remember that scientists aren't introducing anything new to the body. They're simply amplifying the body's natural ability to fight back. And because of this, these checkpoint inhibitors have actually become one of the most promising first-line treatments for many types of cancers. Now, as we talk about this, let's take a moment to truly grasp the importance and the magnitude of the impact that biomarker testing has had. To put things into perspective, consider this. The widespread use of something called the Pap test, a simple cell-based biomarker, which a majority of you have all either heard about or done on yourself, has actually led to a widespread 99% reduction in deaths caused by cervical cancer. Take a moment to let that sink in. 99%. The power of biomarkers isn't just theoretical, it's already saving lives. And the future holds even more potential, driven by breakthroughs in artificial intelligence, or AI. See, cancer is complex. It mutates, it adapts, and it hides in ways that makes it impossible to detect. But this is exactly where AI comes in. See, because of its machine learning algorithms, it can now identify biomarker data beyond human capability, helping make diagnosis a lot more precise than what it used to be before. Now, but you may be wondering, is this data really that important? And the answer is yes, it is. And one of the most powerful examples of this is the UK Biobank, which collects health and genetic information from 500,000 participants. By then linking this information to their health records, scientists and doctors now have an unprecedented resource for understanding disease at the deeper level. Now this matters because the more data we have, the better we are at identifying patterns, risk factors, and predictive biomarkers. More than that, we can now identify correlations between different genetic mutations and their health outcomes, leading to earlier interventions and more precise treatments. Now, in truth, this all leads us towards a future where medicine is no longer reactive, it's proactive and driven by innovation. Because in a world that never stops moving, biomarkers are propelling us forward, transforming cancer care in its entirety. Unfortunately, not everyone is benefiting from this revolution, and that needs to change. See, right now, the majority of breakthroughs in biomarkers are actually happening in major research hospitals, like MD Anderson and Mayo Clinic. The scientists working there are at the forefront of discovery, constantly integrating new science into patient care. But what about the local doctors and practitioners who are the ones treating the majority of cancer patients across the country? Well, they don't always have access to this information in real time, and that's where the disconnect exists. And because of this disconnect, there's a significant gap in medicine that is not talked about enough. It is this gap that forces patients, especially those in underserved areas, to default to the same generalized one-size-fits-all treatment, even when biomarker-driven therapies could offer them a better alternative. This is exactly why awareness is just as important as innovation. It's not enough that we have life-saving technology, but we need to ensure that it reaches every patient, no matter where they are or who their doctor is. And it's also important that all of us do our part in spreading this information. So the next time you know somebody with cancer, ask them, talk to them about biomarkers, because you never know what impact one conversation can have on someone's life. Because in the end, biomarkers are not just numbers on a lab report. They can be the difference between life and death.